In this video, we will discuss about rotating the box. You are given an M cross N matrix of characters box representing a side view of a box. Each cell of the box is one of the following: a stone hash, a stationary obstacle asterisk, and an empty cell. The box is rotated 90 degrees clockwise, causing some of the stones to fall due to gravity. Each stone falls down until it lands on an obstacle, another stone, or the bottom of the box. Gravity does not affect the obstacle's positions, and the inertia from the box rotation does not affect the stone's horizontal positions. It is guaranteed that each stone in box rests on an obstacle, another stone, or bottom of the box. Return an N cross M matrix representing the box after the rotation described above. So what they are saying is that in the input we are given an M cross N matrix, which is this. So it has three types of characters: a hash, which denotes a stone, an asterisk, which denotes an obstacle, and a dot, which denotes an empty cell. Right. Now what you need to do is that you need to rotate this matrix by 90 degrees clockwise. Right. We need to rotate this matrix 90-degree clockwise, and once you do that, then what will happen is that all the obstacles, all of them will remain at their original positions, but the stones will fall due to gravity. Now these stones will only fall into empty cells, and also if there is any obstacle in between, then these stones will rest on these obstacles. Right. So let us understand in detail. So firstly, these characters are a little confusing. So what I will do is that I will change this matrix to contain S for the stones, O for obstacle, and E for empty. So you will be easily able to understand it. So I have changed all the characters now. Right. So if you see, when we are going to rotate this matrix by 90-degree clockwise, then what will happen is this first row will become the last column, right? The second row will become the second column or the second last column, right? And this last row will become the first column, right? So that is what will happen when we will rotate it by 90 degree, right? So when we do the transpose of a matrix, right? Whenever we do the transpose of a matrix, in that case, what happens is that the first row becomes the first column, second row becomes the second column, third row becomes the third column, and so on, right? So basically, if my matrix looks like this: 1, 2, 3, 5, 6, 7, 4, 8, 9, 2, 7, 6. Right. Now, if I will do the transpose of this matrix, then the first row will become the first column, which will be 1, 2, 3. Second row will become second column, 5, 6, 7. Then 4, 8, 9, and then 2, 7, 6. So first row became the first column, but in our case, the first row is going to become the last column, right? So what we can do is that first we can identify the transpose of our matrix, right? And then we can swap the columns. So basically we can swap the first column with the last column, second column with the second last column, third column with the third last column, and so on. If we will swap them, then we will be able to get our desired rotated matrix, right? So we will come to that later, that how are we going to implement this thing. So first let's understand, once we have rotated the grid, what is going to happen with the stones. So as I said, that the stones are going to fall due to gravity, right? So when you see at this first row, so it will become like this: S, S, O, E, O, E, right? Now you need to fall these stones, right? So see, this is an empty cell, then that means here a stone can come, right? This is an empty cell, so here a stone can come, right? But here if you see, this is an obstacle, this is an empty cell, this is an obstacle, right? So if you will see, for this stone, in which cell is it going to fall? Nowhere. It will remain here only. Why? Because just below this stone we have an obstacle, and a stone cannot cross an obstacle, right? That is why this stone will remain here only, and this stone will also remain here itself, because just below it there is another stone, and a stone cannot pass another stone, right? So this is going to remain as is, right? Now if we look at this particular row, so this is S, 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 O, E, E, right? Now again if you will see, here empty, empty, obstacle. Now where this stone will fall? Nowhere, because we have obstacle here. This stone will also not fall, there is another stone. This also will not fall, there is another stone. So this is also going to remain the same. Then let's come to this particular row. So this is S, 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 E, 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 right? Now if you see, This is empty, this is empty, this is empty. Now for this stone, there is no obstacle or any other stone in between, right? So what will happen is that this stone will fall to the lowest empty cell, which is this one, right? So this stone will come here. So what will happen is that this cell will become empty now, and that stone will come here, right? Now if we see for this stone, again there are no obstacles or any other stone, so it will also fall to the lowest empty cell, right? Because of gravity, it will always fall to the lowest empty cell, which is this, right? So this will become empty now, and this will be filled with the stone, right? Similarly for this stone, this is the lowest empty cell, so it will fall here. So this cell is going to become empty, and here we will have our stone. So this is going to be our final matrix, which we need to return as our answer, right? So this was an M cross N matrix. You need to return this N cross M matrix as your answer, right? So see, how are we going to approach this? So firstly, I will just write down that I will be denoting M with the number of rows in the original matrix. Okay, so it will be rows. So these are the number of rows in the original matrix, and N will be the number of columns in the original matrix, right? So here number of rows are 3 and columns are 6. So it is a 3 cross 6 matrix. This we need to create N cross M, so it will be 6 cross 3. So 6 rows and 3 columns, right? So now what we will do is that we will declare these two variables M and N. We will take the number of rows and number of columns in the original matrix, and then we are going to create another matrix of size N cross M. So it will look like this, and initially we will keep all of our cells as empty, right? So in this matrix, we will have all the cells as empty. So this is what our matrix is going to look like. Now what we need to do is, see, first let us identify that what is going to be the new index of every cell. So see, there are two approaches of this problem. First is that first you perform the transpose of this matrix, then you do the reverse of the columns, and then you apply the logic of falling your stones, right? But we can shorten this process, and what we can do is we can directly create this matrix. We can keep all the cells as empty, and then we can identify that for every cell in this matrix, what is its index going to be in the new matrix, right? So see, whenever we do the transpose of a matrix, then what happens is if I comma j, if I comma j was the original index of a cell, then after the transpose of the matrix, the new index will become j comma I. The row and column will be reversed, right? Now in our case, what are we doing is that first we are transposing it and then we are reversing the columns, right? So when you will do the transpose, then the new indexes will be j comma I, right? And then you are reversing the columns, right? So in that case, row is going to remain the same, j is going to remain the same, but this I will change, right? Because we have to reverse the columns. So now what will be the value of this I? So first column is becoming last column, second column, second last column, right? So can I say that this will be j comma m minus I 1? So see, if we see here, this cell has an index 0 comma 4, right? If I write it here 0 comma 4, what will be its new position in this matrix? This, right? Because this will become this, and this is the cell, so it will become this particular cell. Here it is 4 comma 2. So the new index is 4 comma 2. So if you see, original index was I comma j, that is 0 comma 4, and we are saying that new index will be j comma m minus I minus 1. So here j was what? J was 4. So in the new index, this will be 4, right? And next is m minus I minus 1. What is m? M is the number of rows, right? Number of rows is 3. So it will be 3 minus. What is I? 0. 0 minus 1. So that is 2. So the new index will be 4 comma 2, which is what we had expected, right? How did we derive this m minus I minus 1? Because we are reversing the columns, right? And whatever are the rows in the original matrix, that will be the columns in the new matrix, right? That is why we considered m minus I minus 1. right? So this thing we have to keep in mind. I'll just write it here that our indexes I comma j will be changed to j comma m minus I minus 1, right? Because in our case, we won't be doing first the transpose and then the reverse of columns. We will directly create the new matrix, and with the help of this formula, we will identify the new index, right? So now, when you have this matrix, how are you going to achieve this particular state? So see, first we need to go column by column for updating, right? So what we will do is, if I remove this, so first we will run a for loop which will start from I equals to 0 till m, right? So this will go for all the columns. So m is rows here, which will be columns in this particular case. So we are going into the columns one by one. Now that I am considering one column, then what I want to do is that for every stone, I want to fall it to the lowest empty cell available. Lowest empty cell which is valid, right? There shouldn't be any obstacle in between. That is also we need to keep in mind, right? So what we will do is that we will take some variable, let us suppose lowest, which will tell us that which is the lowest empty cell or which is the lowest valid empty cell, right? Now, initially, can we keep it as n minus 1? Why we are keeping it as n minus 1? Because n is the last row here. Last row, right? Here, n was denoting the column, which was this, and this is going to become the last row, right? So, we are assuming that right now we have just started considering this particular column, so we don't know that what is the valid lowest empty cell, right? So whatever is the lowest cell, that we will keep as one of the valid empty cells, and then we will try to find out the valid one and we will update this lowest, right? So that is why we are keeping the lowest to the last cell of that particular column, right? Now what we need to do is we need to go inside this column one by one for every cell, and we need to check if it is a stone, then what we need to do. If it is an obstacle, then what we need to do, right? So we will run another for loop of j, which will start from n minus 1 and it will go till 0. Why is it starting from n minus 1? Because we want to go from bottom to top, so that every time we can identify that what is the lowest valid empty cell and where the stone should fall, right? Now inside this there are three cases that either the cell will be a stone, an obstacle, or an empty cell. If it is an empty cell, we can ignore it, right? But if any of the cell is an obstacle, in that case what you will do? So if that cell is having an obstacle, then what is it telling you? That neither of the stones can go beyond this obstacle, right? Whatever stones will be present above that particular obstacles, they can never come below this, right? So whenever I have encountered an obstacle, can I say that I should update my lowest to the current cell minus 1? Why? Because see, if let us suppose this was an obstacle, right? If this is an obstacle, then whatever stones are above it, they cannot come beyond this obstacle, right? So since this is an obstacle, a stone cannot come at this particular cell also. So what will be your lowest empty cell? That will be this particular cell which is just above the obstacle, right? So what we will do is that whenever your box of I of j is equals to, so this box is the original matrix, right? And I of j, whenever it is equals to a asterisk meaning obstacle, right? So whenever it is an obstacle, at that time we will do two things. First, we will update our lowest to j minus 1, which is current row minus 1, and then that obstacle should also be updated in our matrix, right? Because we need to return it in our answer, right? And if I comma j in box is an asterisk, then inside our answer, what will be its index? It will be j comma m minus I minus 1, right? So if I denote this particular matrix with result res, so what we will do is that inside res at j comma m minus I minus 1, we will update it to an asterisk. So this is sorted. Now the other cases when the box of I comma j is equals to a hash, which means a stone. Now, when the current cell is a stone, then you need to fall it to the lowest empty cell, right? And what is the lowest empty cell? This lowest, right? We are keeping this lowest variable to denote the lowest cell, right? So now, whenever it is a hash, what will you do? So the row is being denoted by lowest, and what will be the column in result? M minus I minus 1, right? So what we will do is that in res, the row will be lowest and the column will be m minus I minus 1, and we will update it to a hash, right? And now since this particular lowest empty cell is now occupied by this particular stone, then that means we should decrement our lowest by 1. Whatever is the cell that is just above the lowest, that should now become the lowest empty cell, right? So this is the only thing that we need to do. And at the end, you can return your result, right? So now let's do dry run for one of the columns so that you can understand it better. So here it was changing, right? Here the stones were falling. So this is a better example. So when you will be considering this particular row, at that time your I will be 2, right? And your j will be what? J will be n minus 1. N is the number of columns, which is 6. So it will be 6 minus 1, that is 5. And what will be your lowest? Lowest is also n minus 1. So this will also be 5, right? So now when you are coming inside this loop, you are checking if box of I comma j is equals to a star. That is an obstacle, right? What is I comma j? It is 2 comma 5, right? What is present at 2 comma 5? Empty cell, right? So this condition is also false and this condition is also false. So we will move forward and our j will be decremented by 1. So it will become 4 now. Now our indexes are 2 comma 4. Now what is present at 2 comma 4? Again an empty cell. So again both the conditions are false. J will be decremented by 1. New index is 2 comma 3. Again at 2 comma 3 an empty cell is present. Again both the conditions is false. J will become 2 now. Now our indexes are 2 comma 2. Now you will see that at 2 comma 2 we have a stone present. Stone is a hash. So it will come inside this condition. Box of I comma j has now become equals to hash. So now what will happen is, what are we doing? That at lowest comma m minus I minus 1 you put a hash, right? So see, what will happen? What is the value of lowest? It is 5, right? And what will be the value of m minus I minus 1? So m is 3, right? I is 2 and that is 1. So it will be 3 minus 3, that is 0. Then that means at 5 comma 0, we will update it to a hash inside our result, which is this particular cell, right? So here instead of E, we will have an S, right? Now the next thing is that we are decrementing the lowest by 1. So now our lowest will become 4. So if you closely look here, this is an empty cell, right? Here a stone has come. So if there would be any other stone that will fall, which is present above it, it will never go beyond this particular stone. That is why lowest is 4 now, right? So now again what will happen is that j will decrement by 1. So it will become 1 now. Now the index is 2 comma 1. At 2 comma 1, we have again a stone, right? So again this condition will hold true. So now what are we doing is, lowest is 4 and m minus I minus 1 is 0. So at this particular index, again we are going to have a stone, right? And the lowest will become 3 now. It will be decremented by 1. Now j will become 0. Then at 2 comma 0 we have a stone. So again this condition is true. Now inside this lowest is 3. M minus I minus 1 is 0. So at 3 comma 0 we will update it to a hash. So this E will change to a stone. Empty cell will change to a stone. So here I am writing this S, O and E just for the sake of your understanding. But here if you closely look, we are adding a hash here and here an asterisk, because that is what is expected in your matrix. right? Now j has become 0, lowest is 3, now lowest will become 2, but now j will become -1 and you will come out of your loop. So you will be done for this particular column, right? So is this what we wanted? Yes. So I just did a dry run for only one of the columns so you can understand it better. You can try it for all the columns and you will be able to identify that what will be the answer. Now in this particular case, we would be creating a resulting matrix of size n cross m, right? So our space complexity would be n cross m. And what will be the time complexity? Here we are running a for loop m times and here we are running a loop n times, right? So our time complexity will be n cross m. So let's quickly code it out now. So first of all, we'll create a variable m which will store the number of rows, which will be box dot size. And then we will create another variable n which will store the number of columns, that is box of 0 dot size. Next we need to create a vector of vector which will be our result, right? So it will be vector of vector, it will be type character and we will name it res. What will be its size? N cross m. So n comma vector char m, and initially we are keeping all the value, all the cells as empty, so we will write a dot here, right? Now we need to run a for loop for our columns. So int I equals to 0, I less than m, I plus plus. Then we will create a variable named lowest which will denote as the lowest valid empty cell. So it will initially be n minus 1. Then we will run another for loop of j which will start from n minus 1. It will go till 0 and will do j minus minus. Now inside this we need to check that if box of I comma j is an obstacle, if it is equals to asterisk, then in that case in our resulting matrix also we will update it. So it will be j comma m minus I minus 1. So this will become an asterisk now, and now our lowest will become j minus 1, which is the cell just above this obstacle, right? Else, if our current cell box of I comma j is a stone, that is a hash, right? In that case what will happen is that we will fall that stone to the lowest empty cell. So we will do result of lowest comma m minus I minus 1. So it will be equals to a hash, which is a stone, and we will decrement our lowest by 1, and at the end we will return the result. So let's quickly run this now. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.